Today, let's take a look at higher order derivatives. When we have a function, such as x to the fifth minus x squared, we can take the first derivative, bring the 5 down, take 1 from the exponent to get 5x to the fourth, bring the 2 down to get minus 2x. We can take a derivative of that derivative. When we do that, we say f double prime of x equals, bring the 4 down, 4 times 5 is 20, x to the 4 minus 1 is 3, minus, and we take the coefficient of that 2x, remember, because that's a line, and the slope is the coefficient of the linear term. Now, what you see here, these double prime, this is f prime, f double prime, so we just put a tick mark to denote that we're taking the second derivative. For the third derivative, instead of using 3, we turn it into numbers instead, because otherwise that could get out of control really fast. So let's take the derivative of the first term. 3 times 20 is 60. X to the 3 minus 1 is 2. Derivative of constant is just 0. Now, we could keep going. We could do the fifth derivative of x. We could do the 17th derivative of f of x, right? So we could just keep going and going, remembering that this guy here, that what looks like an exponent but isn't, it's a superscript. This superscript tells you how many times to repeatedly take the derivative. Take it once, twice, 3 times. We have to take a look at the notation as we go through this, because here we have that 2 hash marks there, tick marks, to mean the second derivative. Now, this guy is saying take the third derivative of g with respect to x. Then we get this ugly looking thing. And the reason why we have this notation, this is taking the second derivative of the function a with respect to x. We are soon heading to multivariable functions where we're going to have y's, x's. We're going to take the derivative of y with respect to x, of x with respect to y. And so we've got to have this new notation. So this guy, he's coming soon to a math classroom near you. Now, let's go ahead and do one together. Here's a function. We want to find the sixth derivative. So we find the first derivative, we use our single hash mark. F prime is equal to, bring the 5 down, 10 x to the fourth. 2 times negative 9 is negative 18, x to the first. That's the first derivative. The second derivative, we say f double prime of x is equal to 4 times 10 is 40, x to the 4 minus 1 is 3, and then minus 18. We can go again. Remember, we changed to numerals for that superscript. Third derivative, we take the derivative of the second derivative. 3 times 40 is 120. X to the 3 minus 1 is 2. Derivative of a constant is 0. We got to keep going. We're looking for the sixth derivative. So the fourth derivative, bring the 2 down, and you get 240 times x. Now we need the fifth derivative. Derivative is the coefficient of the x, 240, and then we can do the sixth derivative. We take the derivative of the fifth derivative, and the derivative of a constant is 0. We could also keep going. We could go all the way up to the 17th derivative of this function, but anything after here, every one of those is going to be 0. Now, this whole process can get really ugly really fast. So when we're looking at this, the first one, we're looking here for a third derivative. Well, we could FOIL this out to get a polynomial and then do power rule, power rule, power rule. It will be much easier than trying to do a product rule on this. This guy, though, we've got a third power here. We would have to multiply this by itself three different times, and then we would have to have times this. That's going to be a mess. So instead, we're going to use the product rule. Derivative of the first times the second plus the first times the derivative of the second. That give you the first derivative, then do it again. As you can see, that's going to be really ugly and messy. Now down here, you just, as a wreck, right? Because it's going to be, for us, a quotient rule. We could factor the numerator to x plus 1, x minus 1, but we can't divide out. So we're going to leave it like this. P and Q, use the quotient rule. You're going to get a very long quotient, and you're going to need to simplify, then take it again. So ugly fast. So we just want to pay attention to our derivative rules as we can. And remember, higher order derivatives is just saying do the derivative again, take the derivative of the derivative, take the derivative of the derivative of the derivative. Hoping you have a amazing day.